Welcome to this movie about friction. I have here a box on the surface and I exert pushing force on it, and there will be a frictional force in the other direction. And we're going to study this frictional force. Why is there a frictional force? It's because the surfaces are not perfectly smooth. There is an irregularity in the surface here and here, and they just block each other at these points. There is a certain blockage. So that causes the frictional force. When there's no movement, I know that the net forces are zero. So the pushing force equals the frictional force. The force of the push can rise as long as there is no movement. The frictional force rises the same amount. So if my pushing force is zero, the frictional force will be zero. If I push with 10 newtons and there's no movement, there will be 10 newtons frictional force. Until a certain maximum point. The frictional force equals the constant here you see times the normal force. When this is equal, the frictional force equals this one, there will be movement, or this will be the maximum frictional force possible. So sometimes we write it like this, because the frictional force of course can be zero. When I do not push, it's zero. So this force can be between 0 and this value. When I am at the point of just starting to slide, the box just started to slide, at that moment the frictional force will be equal to the normal force times the static coefficient of friction. When there is movement, I have the same formula, only use a different constant. It's the kinetic coefficient of friction, which is a little bit lower, or much lower, it depends on the situation, which is in any way case lower than the static coefficient. You will have noticed that when you push against a certain heavy object, it takes a while before you have to exert some force. It takes a while before it starts to move, and when it starts to move, the force you have to use to keep it moving is lower than the one you needed just to get it started. Of course, to get it started you need also a net force which is bigger than zero, or you cannot start it to bring it into motion. When you're pushing it with the constant motion, net force is zero again, but still the frictional force is larger at the moment just before you start sliding. When the object accelerates, the pushing force is bigger than the frictional force. Of course, or we have no acceleration because we need a net force. When the object has a constant speed, we know again it's the same like when it's static. The pushing force equals the frictional force, only the constant will be different. Now we have a way of experimentally measuring the coefficient of friction. When I have my object, a box here, and it's on an incline, and we look for the moment at when it just starts to slide down, or when it just not starts to slide down, the moment of starting sliding. So what forces do we have in the box? We have mg, we have the frictional force, and we have the normal force. And we have some other forces too, but we have also our axis, and we choose the axis according parallel to the x-axis to the direction of movement. So we do like this, x downwards the axis, downwards the incline, but that means that we need to split mg in two forces, one parallel to the y-axis and one parallel to the x-axis. We do that. Parallel to the y-axis we have mj cosine alpha, which is of course here, which trigonometry you can find it. And then we have this one is mj sinus alpha. Well, there is no movement. That's the moment just before we start sliding. And that means that the forces in the x direction, or along the x-axis, are zero, which means mj times sinus alpha minus the frictional force will be zero. And the same for the y direction, because we have no movement in the y direction either. The normal force minus the force downwards, mj cos alpha, will be zero. So that means that in the x direction, mg sinus alpha equals the frictional force, and that the normal force equals mj cosinus alpha. Which means that mj sinus alpha which is the frictional force, equals the coefficient of friction, which we will call mu from now on, Greek letter mu. Mu times the normal force, and the normal force we have here is mj cosine alpha. So we replace Fn with mj cosine alpha. Now we can eliminate mj, and we are left with sinus alpha divided by cosinus alpha is mu, which means that tangent alpha is mu. So you can do in fact a simple experiment. Just take two objects, take an object and a surface, see that you can bring the surface up, and at the moment of just sliding, well, you know that the tangent of that incline equals the coefficient of friction, the static coefficient of friction. When the object is sliding down and with a constant speed, if you can observe that, at that moment tangent alpha would be equal to the kinetic coefficient of friction. And a little example, an object with a 30 kg mass is on a surface inclined to the horizontal with an angle of 20 degrees. The block would start sliding down, but when exerting a downward pushing force of 100 newtons indicated on the drawing, the block is at the point of not sliding. Calculate the coefficient of friction. So we have the same situation as before, except now I'm pushing onto the block. Normally it would be sliding, but when I push, it's just at the point of not sliding. Which means again that the forces in the x direction are 0 and the forces in the y direction are 0. So in the y direction we have the normal force minus mg cos alpha, but also minus the pushing force now. And this one equals this one and this one. The normal force is mj times cosinus alpha plus the pushing force. So we bring this to the other side, which means that the normal force is 30 kilograms times 9.81 Newton per kilograms times cosinus 20 plus 100 is 377 newtons for Fn. In the x direction, we have 0 equals mg sinus alpha minus the frictional force, which means that mg sinus alpha is the frictional force, and the frictional force is 101 Newton. Well, we now have the frictional force and we have the normal force, which brings us to our definition of frictional force is mu times Fn, and mu is divided frictional force divided by the normal force, and we have 101 divided by 377 is 0.268 for our coefficient of friction.